Lesson 6.3, Logarithms and Logarithmic Functions. Our essential question, how do you define, evaluate, and use inverse property of logarithmic functions? Standard 6.3, number 7, graphing a logarithmic function. So we're going to go ahead and graph these. This is our b to the x power, and this is your log base b. They are inverses of one another because your exponent form and your log base form are inverses. And you know they're inverses because this is the reflect line. And if you were to fold, they would land right on top of each other. Same with this. We have our exponent form and our log form, our reflection line. If you folded, they would all land on each other. Now, when would it look like this compared to this? If your base is bigger than 1, yours will look like this. If your base is between 0 and 1, so it's positive, but smaller than 1, they will end up looking like this. So let's go ahead and take a look at our problem. So we are being asked to graph log base 3 of x. I don't know how to graph this. So we're going to try and graph it by using the inverse. So first we're going to find the inverse. So I have y equals log base 3 of x. To find the inverse, the first thing I needed to do is I needed to switch my x's with my y's. So I have x equaling log base 3 of y. And now I need to go ahead and I need to solve for y. So y is a part of the log. I'm used to the log being written on the left and seeing the equal on the right. So I'm going to rewrite it. I need to get out of the log. So we're going to go ahead and write this in exponent form instead. So 3 to the x power equals y. So 3 to the x power equals y. This is my g of x inverse function. So I found my inverse, and I know how to graph this function. So this is what we're going to actually graph. To graph it, we're actually going to use a table. So first we're going to table the inverse. So here's my table for g of x. We're going to do a couple of negatives, 0, and a couple of positives. Plug in these x values into the g of x function. This is what I end up getting. So this is my g of x. This is the inverse. So I need to go ahead and graph it on this. We are going to go ahead and label our xy axes. We're going to go ahead and go straight down the middle. So here's my x and here's my y. I'm going to scale these. I'm looking at it, I'm going to need to count by 2s. So let's go ahead and scale them, counting by 2s. So if this were an inverse function, I'm going to see them right along this line right here would have been my reflection line. It's the diagonal reflection line. So let's go ahead and take a look at that and make sure that they do inverse. So g of x, go ahead and graphing these. So this is what my g of x function looks like. If that is g of x, then I hypothesize f of x is going to be over here. How do we find f of x? Well, remember, if you have the graph, if you have the table of the inverse, you can actually switch your x and y's, and you can find the table of your f. So if it was an x, it is now a y. And if it was a y, it is now the x value. And we're going to now graph f of x. So this is my f of x function. I see if I were to fold here, they would all land on each other. So I found the inverse, so I knew a graph to graph. I graphed the table, and then I used hand switch x and y's to find the graph of the actual function. So next problem, I don't know how to graph this. So I'm going to go ahead and find the inverse first. So I need to switch my x's with my y's. So there's me switching my x's with y's. Now I need to solve for y. But I'm used to reading the log written first. So I'm going to write the log first. I need to get into this y, which means this log needs to go away. How do you make the log go away? You're going to rewrite this in exponent form. So 2 to the x power gives me y. So 2 to the x power equals y. So now I have my g of x inverse function, which is 2 to the x power. This I know how to graph. This I do not. So we're going to go ahead and graph the function we know how to graph. So we are going to graph g of x using our tables. Once we know g of x, we switch your g of x, x and y axes, and that'll actually give us f of x. So we're going to try a few negatives and a few positives, remembering if those are the x's, those are now the y's. So let's go ahead and find g. Plugging these values into the g function, I end up getting, well, if that's the inverse is y's, that meant they're the f's, x's. So I'm going to write them as the x values. And now I just need to go ahead and graph them. So we are going to put our xy axes right down the middle. And we're going to scale by ones. Okay, first I'm going to graph x. So here is my g of x. This is the inverse. I know it has to reflect across this line of reflection line for it to be a true inverse, which means if g is over here, my f function needs to be over here. So let's go ahead and graph f. And here is my f of x function. So I was asked to graph this. I have no idea how to graph this. So I found the inverse and its table, then switched your x and y's and found f. So I had to go through this process to be able to graph f. There's one problem left on the page for independent practice. Please do this for your own.